Hey everyone, today we're going to dive into a big idea made simple: Internet Computer Protocol, or ICP. Imagine an internet where you own the apps, control the data, and even manage the infrastructure. That's the world ICP is building, and it could change everything about how we use the internet. Stick with me, we'll break down what ICP is, how it works, and why it could be a game changer. So, what exactly is ICP? In simple terms, the Internet Computer Protocol is a new way to run the internet. Instead of apps and services relying on big tech companies and their centralized servers, ICP lets them run on a decentralized network. This means no middlemen, just a global community powered internet. The goal here is pretty ambitious. ICP wants to create a completely new type of internet where anyone can build apps that are fast, scalable, and don't rely on traditional IT setups. Think of it as the next generation of the internet, one where you don't need Amazon or Google to host anything. ICP does have some standout features. It can handle massive numbers of transactions and smart contracts, way more than traditional blockchains, which solves a big issue with scalability. It's also incredibly fast. Transactions happen in just seconds, making apps and services built on ICP feel just as responsive as what you're used to today. Plus, it's cheaper to run these apps compared to using traditional cloud services. So it's not only about speed and scale, but also lowering costs. Let's talk about how ICP actually works. It runs on independent servers called nodes, which are grouped together into what we call subnets. These subnets host something called canisters, which you can think of as supercharged smart contracts that store both the code and the data needed to run applications. Now, to break that down even further, canisters are what developers use to build more complex applications. The nodes are the servers powering the entire ICP network, making sure everything runs smoothly. And the subnets are groups of these nodes working together, which allows the system to grow and handle more data as more people use it. To make it easier for developers to build on ICP, the team behind it created Motoko, a programming language designed specifically for this protocol. Motoko is user-friendly and helps developers create secure and scalable apps with fewer bugs. It's tailored ICP's unique architecture, and it simplifies a lot of the complex coding that typically comes with blockchain projects. This is a big deal because it opens the door for more developers to join the ecosystem without needing to learn entirely new skills. Now, what makes ICP really stand out is its speed. Transactions are confirmed within seconds, so apps built on ICP are just as responsive as web apps you're already using. That's a huge plus when you're trying to build a decentralized internet that competes with today's centralized services. Now, how does everyone on the ICP network stay in sync and agree on what's happening? Well, this is where ICP's consensus mechanism comes into play. And it uses two key technologies to make sure everything runs smoothly. First, there's threshold relay, which helps the network reach agreement on transactions quickly and securely. Then we have chain key technology, which allows different parts of the network to communicate seamlessly, keeping everything scalable and efficient. So, what makes chain key technology special? Well, it simplifies the way the network operates. Instead of having to manage lots of different keys, the entire network uses just one public key to verify transactions. This makes things simpler and more secure while keeping everything fast. With advanced cryptography ensuring security, ICP can process transactions quickly without compromising safety. And the best part, as more users and apps join the network, ICP can grow without slowing down thanks to its scalability and ability to be upgraded without downtime. Another key innovation with ICP is the reverse gas model. Unlike Ethereum, where users pay for the computational resources in each transaction, ICP flips that on its head. Here, developers are the ones who pay to run their applications. This means users can interact with dApps without worrying about transaction fees or handling complicated cryptocurrency payments. It's a small but powerful shift that makes the internet on ICP more user-friendly and accessible. Now let's take a look at what's being built on ICP. There are some really interesting projects happening in this ecosystem. For example, DSCVR is a decentralized social media platform that works a bit like Reddit, but with one major difference. Users control their own content. Another project is OpenChat, which is a secure messaging app where your messages are private and don't rely on big tech servers. There's also a lot happening in the world of decentralized finance, or DeFi. We have Sonic, which is a platform that allows for trading, lending, and borrowing without the need for any middlemen. And in the NFT space, Entrepot is a marketplace where you can buy and sell digital collectibles and art. It's all part of this growing ecosystem that's reshaping how we think about apps, data, and ownership on the internet. Now let's talk about the ICP token itself. As of September of 2024, there are about 524 million ICP tokens in existence, with roughly 471 million actively being traded. These tokens serve several purposes on the network. First, they're used to pay for transactions, but ICP tokens can also be converted into something called cycles, which are what actually power the smart contracts, those canisters on the network. Beyond that, if you hold ICP tokens, you have a say in how the network evolves. That's because ICP token holders can vote on proposals and network upgrades. And finally, there's staking. By locking up your ICP tokens, you can help secure the network and earn rewards in return. Of course, with any ambitious project, there are challenges. One of the biggest challenges ICP faces is managing scalability as more people use the network. Balancing resources and ensuring everything runs smoothly as demand increases is a constant effort. Another challenge is node distribution. Right now, a lot of the network is controlled by a few groups, and this does raise concerns about how decentralized ICP really is. While the goal is to become more decentralized over time, this is still something the project is working through. Speaking of decentralization, there are some ongoing concerns about how much control is still in the hands of the Dfinity Foundation, which developed ICP. Now, ICP does have a system called the Network Nervous System, or NNS, which allows token holders to vote on proposals and network changes. The system is designed to gradually move the project towards greater decentralization, but some people still feel more work is needed to get there. Let's not forget about privacy and security. ICP uses advanced cryptography and decentralized nodes to ensure user data stays private and secure. This is crucial in today's world where data breaches and surveillance have become major concerns. With ICP, your data isn't stored on a single server controlled by a big corporation. It's distributed across the network, making it much harder for any single entity to gain access or control. If you're excited to learn more about ICP and the world of blockchain, head over to learningcrypto.com, where we make crypto easy to understand. Whether you're new to the space or already diving in, our community is here to help you every step of the way. So join us today at learningcrypto.com and be a part of a growing community that's shaping the future of finance and technology. Let's keep growing and learning together.